So first of all, the fact that we're talking about this subject in 2024 is a victory for all of us who believe in this format and love it and want to see it survive and prosper, and it is. So again, thank you all. So we're going to talk about what is the future of this? What more can we get out of the groove? And we have assembled a team of really excellent people here who have spent a lot of time in their lives to bring this process forward. So we'll start over here. This is Mark Dohmann, who's a turntable designer of some excellence. Has designed some incredibly good turntables. And we're not going to mention brands. We don't want brand placement to get involved in this. Dohmann Audio. Craig Milnes from Wilson-Benesch, who founded a company as vinyl was going away to build a turntable. So that was kind of crazy, and that's worked out well for Craig, and we're going to talk about his accomplishments too. And Leif Johannsen from Ortofon, who has spent the last 10 years plus designing some extremely high-end cartridges and bringing the whole subject forward. And then we have J.R. Boisclair over here, who has taken over from all of our mentors, Wally Malowich, and brought forward those setup products to another whole nother level and taken this to an extreme. So my first question to the panel is, what has happened over the last decade that has brought this subject to where we are now, that's brought vinyl playback to a much higher level? Because I think everyone here will agree that over the last 10 years, we have brought out of the grooves things that we had no idea were in the grooves. And that the people that invented this in the 50s, they never heard what was in those grooves, which is an irony. So Mark, why don't you start and tell us what you've done over the last 10 years to make this better?
Okay. We are relying on wonderful music that was embedded in the groove back in the 1950s and 60s. Anyone who's heard, say, the Royal Ballet, Keith Wilkinson, the Answer May recording of that, when you look at the back of that vinyl and you see 1959, you go, hang on, they were putting something in there, and only in the last 10 years do we feel that we're finally hearing some of the incredible sonic beauty of those recordings, almost like you were there at the performance. So obviously they did something right back then on that side, which is what I call the landing side, and we work on the takeoff side. And JR, his mentor, was also one of my mentors, Wally Malowitz, and Wally was not backward in coming forward with his opinion. Like he would say, Marco, you idiot, your basics, and he'd reinforce his master's in mechanical engineering. And I realized as a designer that instead of being offended by that, normally you say, oh, he's calling me an idiot for something. No, what he was trying to do was make me think different. And by exposing some of the problems at the micro level from the diamond's perspective, forced me to look at, hang on, that's a problem. I need to address that somehow. I need to start looking at what I can recruit to bring to bear on this problem because it's been exposed. So I guess one of the things here is that it's a symbiotic relationship that's occurring in the industry. It's a collaborative one where we rely on the heat-seeking missiles that JR launches. And I guess, there's a relationship that the cartridge designer, that we rely on your work so that we can take off and create that incredible soundscape. So
Mark, what have you done in your designs that has made a significant difference specifically?
So I identified that we're actually dealing with a nanometer problem. Something that is so small. We're no longer at the thickness of a hair or a couple of thousandths of an inch that you can feel with a fingernail. We're talking stuff that's almost, well, you definitely can't see it with the naked eye. However, with certain tools, we are now realizing that things that are in the groove are as low as 20 nanometers. Perhaps. Okay, we're actually transducing, we're picking that up. That's the realm of microscopes. That's the realm of research departments. That's the mining companies, medical companies that are looking for atoms. So what we thought is, well, what are they doing to clear up their images? What are they doing to make their resolution improve? And so we met with and discussed with the leading designers of isolation platforms in the world, one of them being in California, Dr. David Platis. And I said, David, is there some way that we could integrate your technology that is proven to work in the nanoscale and the angstrom level scale in universities and defense and aviation and space exploring? I want to join that together with what I'm trying to do for playing records. And it was that seed idea and that collaboration that led to the first product that we did that we felt addressed isolation. Now there's a lot of products that are really going the same level. I know Craig's wonderful GMT table is using a laboratory grade isolation system to float that turntable and break contact with Mother Earth. And what is the problem? Vibration from the ground. The laboratories and universities, they're looking for a gold atom in a eucalyptus leaf. Why? Because if they find a gold atom in a eucalyptus leaf, they know the tree that it's planted on is drawing up water and there's gold under there. So that's how the level that gold exploration is getting to in Australia. So ground-borne disturbances from the highway 2 kilometres away is blurring the picture and they can't see. And you can throw 10 tonnes of concrete at it. You can put another 4 tonnes of cast iron on top of it and put your microscope on top, and guess what? It's still blurry. You've got to break contact with Mother Earth to make it think that it's floating in space. And that's a very, very low frequency solution. Air systems that go very low frequency. We use a mechanical spring system that's very low frequency, and it cuts out that road traffic. Now, what is the noise in your room? It's a loudspeaker. It's your subwoofer. It's your kids running up and down the hallway on a wooden floor. It's an old English house with a compliant wooden floor and the washing machine next door rattling. There's all forms of this environmental noise. So having something that's rigid and a high mass, it won't get rid of all of that vibration. So what we try to do is take it to that nano level.
Just a brief interruption, esteemed viewers. As you may know, I'm Tom Martin, Chief Content Officer of The Absolute Sound. We have a new product. It's on the Substack platform, and we're going to do some interesting things with Substack. First of which is reader questions and answers. Each Monday, readers will submit questions. We'll pick the most interesting ones and we'll answer the questions on Friday. We'll also have early access to articles and special blogs that don't appear anywhere else. We hope you'll join us. It's only a cost of a cup of coffee per month. Just check on the screen or in the show notes below. Thanks. And now back to the show.
Okay, so I have to say this because my partners would be very upset if I didn't say that I'm the editor of trackingangle.com website. They'd be upset with me. And I'm also an editor at large at the Absolute Sound. So, okay. Now, Craig, you produced the first tone arm using carbon fiber, correct?
That's true, yeah. That was nearly 35 years ago now when we got funding from government. We've had quite a lot of funding from government. I think we got over $500,000 for the GMT, which we had to match. So that's the level of investment we've made.
I just have to interrupt and say, as an American, if anybody went to the United States government and said, I want to get $500,000 to do something to design a new turntable, they would laugh them off. They would send
the very first, Wilson-Benesch was launched on a grant. We got our first project where we developed the carbon fiber sub-chassis in the turntable. We got £15,000 and we thought we'd won the lottery when we got that. So it was a tiny amount, really, when you look back on it. But it was that initial input of finance that helped us get off the ground. And part of that business plan was, in fact, that we said vinyl will never disappear. It will be hit by what's happening in the digital domain, but eventually it will come back and become a more esoteric but still very strong medium. And 35 years later, I'm sat here talking to you about it.
Yeah.
So that's vindication for it. I was thinking about what Mark was saying. I don't know how many turntables you've actually brought to the market, Mark. How many? It's not a huge number, is it?
No, if I count back to 1982, as individual models, there's 5.
5. And we've done, the GMT is 3. We've only done 3 in our history. And I think what we're talking about here is quality, not quantity. And what we've been doing is a huge amount of work, but not actually bringing a lot of products to the market. And it just shows how much research is being done that people aren't really aware of. And when we're talking about research, we're talking about working with universities in numbers, not small numbers of universities, to get the research to that level of competence to be able to achieve things that have never been done before.
And what were you researching? What did you find was important to improve upon?
Well, perhaps one of the key aspects of the GMT that we think we've really done something special is the motor. We got funding about 15 years ago to do what was called the Mondrian project, and that was trying to drive with a direct drive motor a magnetically coupled platter, and it failed completely. So that was £186,000 worth of government funding that we didn't have any results from. So to get another grant after failing was quite an achievement, because you, generally speaking, have to prove that you've been commercially successful. But we'd had like 14 other grants before that had been successful, so they were happy to fund another research project, which was $356,000. And that gave us access to a number of scientists in the local university as well as the Advanced Manufacturing Research Centre. So we could introduce all sorts of new materials science that typically an SME would just not access, because just the machine to grow titanium parts is £1 million aerospace machine that normally makes insanely expensive products. So for us to be able to access that funding was crucial. So the motor gave us access to a professor in engineering and mechanics who was like one of the top guys in the local university, a magnetics expert who knew how to manipulate the magnetic flux in the motor to be able to deliver what we required, because the GMT motor, which is called the Amiga drive, is basically a very wide gap flux drive, synchronous motor, and to get rid of the torque ripple, you have to have a very big gap, which is completely contrary to conventional design. So it's not a motor you would see anywhere else in the world other than in a turntable. So that kind of approach is only possible with somebody who knows a lot about magnetics, and we don't know that. We have to go to an expert. So it's that kind of funding that enables this to happen.
And so you think you've solved a lot of the problems that existed in direct drive motors?
Well, your videos that you've kindly done on the GMT have actually demonstrated that, because I think the latest count is about 110,000 views on that.
And they're not the nasty people saying, you can build a turntable for $100, it doesn't make any difference. These are people say, wow, I heard that.
Yeah, it's some good comments. And that's testimony to the effort you put in to bringing this to the wider world. And you should be congratulated for that.
Because this is all about velocity sensitivity.
Yep.
And so if a motor is moving not perfectly, every deviation is creating things that you can maybe not hear outright, but when it's solved, you hear the difference.
I mean, Craig and I, we talk, right? What he just mentioned there about widening the gap. Now, typically in a direct drive system, you have a perfect revolution for one revolution, and you can demonstrate that to everybody, that you've made sure that it's like the guys who are in the 3,000 meter walk, and they have to walk that special way because you've just run. You see, you're not allowed to run, but you have to walk, you see. So there's this stopping and starting that I'm not allowed to go too fast, and it creates confusion in the servo system, and it becomes a jiggly system. So what Craig's done is he's split the gap, so that as it's correcting, it's doing it so gently, but it's not. What do we pick it up? What's
cogging.
our measuring gear? It's this, and we hear it,
Yeah.
even through YouTube videos.
Yeah, that's what's so funny.
So it's redefined what I think direct drive technology can do. Now, in 1970, there was a perfect direct drive built, and they made millions of these direct drives, and it's never been bettered. You know, if you follow the marketing. However, Craig had that problem. We've all seen the problem. Why didn't you use another Technics direct drive? Why didn't you use another well-known Japanese direct drive? And sorry, I love Technics drives. I play them, right?
Because it brings a lot of quality to people for not that much money. So we
Exactly.
love that.
So why did you go to that extent, Craig? What was the problem you were trying to fix?
Well, we all know what direct drives do. They start up really quick and they chug around really like unstoppable. But there's always a price to pay for that particular characteristic, and that is cogging. So in the GMT, we get down to 0.00134 Newton meters of torque ripple, which is almost immeasurable.
Immeasurable.
And you hear it, even if you don't know what you're hearing, you hear something that makes you go, oh. And that's what the readers and the viewers on YouTube
It's
hear.
one of the reasons that I've hung on to the belt drive system, which is technically imperfect compared to a direct drive.
But you filter out the problem.
Yeah, I'm trying to achieve the same goal. We're working to climbing the same mountain. We're trying to get to the same area through those means. So I think in terms of have we reached peak analog yet? I don't think so. I mean, you're seeing this occurring. These new, Craig's got the bone and he's got into it. I don't know whether you've seen the show here. There's a new tone arm that's been roughly in the last 2 years. It's started to filter through. Last year it launched, got a lot of attention. This year we can see it in multiple rooms. It's a whole new way of doing a pivot, and it's not high cost. In fact, it's incredibly cheap compared to the market conditions. But it solves fundamental problems in tone arm design that none of us have been able to fix for the last 50 years. Now, if we said that there's no more development happening in analog, there's proof that a fresh idea from a new, very, very intelligent, clever designer it has upset the apple cart. But the benefit to the vinyl community is they can access that at a relatively affordable cost and get an incredible boost in performance.
Okay, so now we've talked about the turntable side. Now let's get to the transducer side, which is so critical to all of this. So Leif has been very busy with that for the past decade, at least.
2 decades almost.
And I remember coming to this show and meeting you, and you started by dropping a rubber thing on the ground, a little ball of rubber, and it bounced and it bounced and it bounced. And the next ball of rubber dropped and stopped. And then you showed me selective laser melt technology designing the shape of a cartridge that could never be machined. And so why don't you talk about what you've done for the past 10 years or 20 years and all of this?
20 years almost, yeah. Yes, well, first of all, the two subjects we just addressed, stability, both when it comes to referring to ground and also speed. That means everything, in my opinion, because what we are talking about is about timing. If you're talking about the revolutions, and it has to be stable, because if it's not stable, it goes directly into the music. It's not. It's like you have an amp. What comes into your power cord, well, goes directly out to your loudspeakers. So this is extremely important. So I'm happy to hear it, and this nano sort of size we are talking about. Yeah, it's incredible. Normally when I have a fun talk to people, then I would say, now I'm going to talk about something which we cannot do. This is basically impossible, because how would we ever get nano size signal out of this groove? Because we don't have any probe which is nano size. So it's for me, definitely at the beginning, I needed to learn what is in the groove. What is the groove like? Because if I don't know what the groove is like, I cannot make a cartridge that can take the signal out of it. And I think these two things goes extremely together. You need to think about both at the same time. And one of my philosophies in designing cartridge, apart from really learning about the groove, is also to figure out how can I reduce loss. If you have a transducer, and this is now the transducer where you have to take the groove shape through, that then becomes a velocity because it rotates, to a voltage. So you have to make this transformation, and in every transducer, when you have to make a transformation, there will be some losses. This is how life works. And also in the design, there will be some compromises. So for me, it's been really to overcome the losses and overcome the compromises to get the best thing out of the groove. And I would put it in this way that you need to have a housing that can connect safely to a tone arm. And you want that housing to make sure that your magnet system is where it's supposed to be, and it's exactly in this position, because you want the stylus at the end of the cantilever to do the job perfect in the groove. So the housing, which for many people would be a dumb part of a cartridge, just has to look good. No, it has to have a function as well. It has to be stiff. It has to really make sure that you are in the groove with your stylus, but you also don't want it to add something. You don't want it to resonate. You don't want it to ring like a bell if you make it out of metal. So you want to have both things, damping and stiffness at the same time. And this is where we then introduced SLM, 3D print. SLM is just a metal part, sort of like SLS. So you take powder and a laser and you can weld it together. And then you can design your part, not only on the outside, how you want it, but also on the inside. And this is the crucial part, that you can design it on the inside. And on the inside, we then made a structure that added damping. So you could have a stainless steel body, but with damping inside, not something you put into, it's a structure you build. And this is what I showed Michael that back then, dropping a sort of a really solid stainless steel thing, and then this with damping, and the difference is pretty huge. So it's a very crude way of demonstrating the damping, but this is definitely one of the first achievements we made at Ortofon during the last 20 years, really trying to get this housing perfect. And then you dig deeper into it. The next thing you come to is, of course, a magnetic system. Well, magnetic system, what do you want from a magnetic system in a moving coil cartridge? You want stability. Just as we talked about, you want speed stability. You don't want this to change. And if I want to talk about the magnetic flux density in the air gap, I want that to be stable. So I wanted to build a really strong magnetic system, also in order to avoid to have magnetic material in the armature. Because if you have magnetic material in the armature and that one moves in the air gap, it will affect even the best sort of magnetic fields that you have produced in the air gap. So a very strong, very uniform magnetic field in the air gap together with this non-magnetic armature. That is the way to go, because then it can move all it wants to, and it's not affected by the magnetic field, and it does not affect the magnetic field. So it's sort of independent, and this gives you this extra freedom and possibility to have a really dynamic sound. And now we're talking about stability and everything, and we're talking about timing. We're not talking about frequency response and stuff like that. We're talking about timing, we're talking about dynamics. So our way of measuring this kind of stuff is pretty old-fashioned. So we really want to talk more about the timing that we are talking. That is the important thing, because timing is music. You don't hear frequency response. You're hearing ears and brain. That's about time, how that comes into your head. So this is the way you also have to think if you want to evaluate it by measuring. Of course, we evaluate by measuring, but also by listening. Listening is everything if you talk about really getting the best out of the groove. But you also want, as a scientist, you want these two things sort of to go together. If you make a measurement and you don't understand it by what you are listening, then what is going on? And then you dig into this. So getting these two aligned is extremely important for me as a scientist. Now when we dig a little bit further down, we're down to the cantilever level now and to the stylus. Then it's about material. It's really about material. What do you want from a cantilever? What do you want from a stylus? From a cantilever, you would really want this to be stiff. So any movement out there from the stylus, you want that to go directly to the armature. You don't want this to bend or do anything that is unwanted. You really want it to go directly to the armature to get this movement into the armature and then get voltage out. So stiffness, and there are different possibilities. Over time, people have used ruby, sapphire, boron, but a few years ago, 5 years ago, in fact, we then reintroduced diamond. We were not the first company using diamond as a cantilever. It's been used before, back in the sort of the good old analog days, before it went down and now up again. So, but anyway, we reintroduced diamond as a cantilever material because diamond, this crystal structure you have, we had a monocrystalline diamond structure, of course. That is maybe the best thing you can choose. At least this is my preferred choice at the moment. And this is what I often say when I talk like this, at the moment, because we are not static in what we're doing. We're always thinking ahead. And this is what I think all of us do. We think ahead, what could the next thing be? So at the moment, diamond cantilever is the best we can use. And then stylus, well, when shortly after I joined Ortofon, of course, I had to review everything they had and figure out. And then this Replicant 100 stylus that they've been having since, again, the heydays of vinyls, that was really my cup of tea. That gave me the sound I wanted to. So we had that together with the manufacturer, improved a bit by extra polishing and really taking care of that you have the correct radii, both the big radius where you go down into the groove, but also the small one where you really want to go into all the small wrinkles. And with that one, at the moment, at the end of a diamond cantilever, this is what we think make music. And of course, we are talking about making music. It requires that you do the correct alignment and stuff like this, but I think we have a gentleman over here who would touch on that subject, so I won't touch on that. But anyway, it's about really making sure, so if you want to have the best, it takes something from you. You cannot just put it up, press play, and then it's running. You need to do something to get it the best out of it. But right now, as I say, Replicant 100. And this is what we think is the best to go into the groove. But even, you know, the small radius is 4 or 5 microns. We're talking about nanometers. So, well, yeah. So we are having a...
Leif, one of the things that we actually have to... We work together.
Yes.
Because if I was to build a platter, and Craig, chime in here, and I was to place, say, materials that can affect the magnetic circuit at uniform places around that platter, as that non-magnetic, magnetic, non-magnetic, magnetic material is rotating and coming under that cartridge, if I look very, very carefully, I can see the eddy current effect come in and it pulls the suspension down and it creates this little bumpy ride.
Yeah.
Now, you have to be able to observe that. Now, if we were to get a microscope and a video at high frame rate, now we're talking about bullet cam type rates here, 100,000 frames per second, we would see these artifacts and then we would realize that perhaps that is not a good thing to do from our perspective. So then we would change our design mind to say, maybe I need to create the least possible eddy current disturbance for Leif's cartridge to perform like he's wanting it to perform. So
Yeah. Please do so. Please do that. Yeah.
Okay, let's get on to JR, who has made a lot of enemies in the cartridge building business and friends among consumers. He's been examining quality, and he's also been working on proper alignment and setup. And so why don't you talk about some of what you've been doing for the past bunch of years?
Yeah. Well, thanks. First, I want to answer this question. Has vinyl playback technology gone as far as it can go? And answer is an emphatic, absolutely, positively no. And there are two main reasons for that. One, analytical powers that we've got available to us now in 2024 versus just even 10 years ago. Some of these things have become affordable to us now. Infrared
Interferometers.
the laser interferometers, the X-ray diffraction, right? But
Diffraction
we're looking not at only at what's happening to surface materials in frequency and amplitude on the surface, but in the case of X-ray diffraction, what's happening inside the center of that. And so my friends here are using this these analytical powers that didn't previously were available to us.
Where would we be without digital technology?
I know.
Forward.
Totally agree.
Exactly.
That's one of the great ironies.
Thank you.
Digital's been the greatest breakthrough in analog.
Yeah.
So seriously, the software has got so much better. I mean, the big end of town has been able to afford these tools, and without grants or some access or friendships in the big learning centers and being able to access these tools and start to play with them with guys who can drive the tools, we wouldn't be able to push analog forward.
Yeah.
I think digital is very important.
Yeah.
In
Definitely.
Why don't you talk about what you've discovered?
So there's the analytical powers that you guys are employing, and I'm doing some of it as well. But then there's just the other main answer why the answer to that question is no, is we haven't properly employed the basics of physics and geometry to what we use, and we often attribute, when we make a change to the tone arm or the cartridge alignment, we attribute what we hear to the wrong thing because we don't understand all of the variables. And I'm sorry, there are a lot of variables that go into what we end up hearing through the speakers or our headphones. We've been completely, until now, people are starting to become appreciative of the fact that, yes, we are dealing with a mechanical transcription system where we have to pay attention to the nanometer level. And we're talking features in the groove content that cannot be seen by the most powerful optical microscopes because, well, once you get below 350 nanometers, that's below violet wavelength. And we're dealing with way sub-micron signals. It's incredible that we get the quality that we do and that we have over the decades, but there's most definitely more to get. It's just so certain. So I've been really digging into what are the parameters that we haven't been that go into this transcription process.
And what have we gotten wrong over the past couple of years? Or what are we trying to get right about what we tell people about setting up their turntables and their tone arms?
Well, so let's start with there are 7 on the playback side. There's 7 alignment parameters in 1 linear dimension, 2 forces, and 4 angles. I'm not going to go into the education side for that. You can go to all my videos for that. But it wasn't even apparent to us, to me certainly, and I think Wally had only started opening the door.
Wally opened the door.
Yeah,
Yep,
he opened the
without a
doors. There's
doubt.
no way I could do what I do today without Wally and without Michael Fremer's support.
And it's not the Bearwood, Lofgren, Stevenson unit in arguing. That's not that. This is
No.
This is,
No.
Yeah, go.
No, the alignment scheme you choose is an order of magnitude less than the problems that we haven't even started taking a look at yet, right? So and I'll just tell the story quickly about Zenith Air, okay? Zenith, because it's important to the answer to this question. Zenith Air is the degree to which, if you draw a line between the left left channel contact point of the stylus and the right channel contact point of the stylus, it's the degree to which that line is not perpendicular to the center of the cantilever. When we align the cantilever, it's actually a proxy for that assumption, okay? But the industry has tolerances. So we were looking, and they have to have these tolerances, right? This is complex miniature assembly that they're putting together. Because we wanted to look deeply into what is the problem with Zenith Air and what does it present to us. We started with computative analysis, finite element analysis. Great. Now we're starting to understand it mathematically. Then we did subjective analysis. Can we even hear the improvement, and to what level of discretization? By the way, it turns out to be a half a degree, which shocked me. I didn't think a half a degree was possible, that we could perceive it. And then the next portion we had to look at is, what does it look like electrically? Well, for that, you need a test record. All right. So I've got a stack 12-inch high of laboratory test records, the NAB, DIN series, CBS Labs. So we started looking at what's going on electrically. And we were shocked that we were not finding what we thought we should be finding. It wasn't working out mathematically. So we had to, and this is the reason why we're at least a year late for writing our scientific paper on this single subject, Zenith Air. We had to dive into what's happening at time of cutting. And then we found tons of opportunities where there's slop there too. Asymmetrical cutting styluses, which guarantee crosstalk cut right into the groove. We see lots of those. Cutting Zenith Air, there's the degree to which the engineers do what they do. They're all aiming at the same angles, but their ability to hit them is very limited because they don't have the tools. They make beautiful sounding records regardless. All right. We know this, but they can sound better.
And the other point I want to interrupt for a second is that you could put a round stylus on a cartridge, put it in the groove, and it'll still make beautiful music. That's what's great about this.
But it's a mechanical certainty that it cannot extract everything from the groove.
That's right.
Right? So I'm just so excited that just on the level of basics, the employment of proper transcription regiment, right? That there's so much opportunity just there.
I think I also know you enjoy the thrill of the hunt. You know what I mean? To find that.
Yeah.
To get to the final end point. And we had a joke amongst us is JR's like the guy where Chernobyl's happened, and you go, JR, can you go in and find out what's wrong? And we'll watch it from a distance. And he's going to uncover all these things. But that's to the industry's advantage, we feel, because if we follow closely and oh wow, we get new learnings, and it drives our thought processes on how we can improve to get upstream. So I think we're just starting analog. It ain't over. It depends on whether, if you want to make a lot of product, etc., you don't care about these things necessarily. A conical stylus in a great, old vintage table, it still makes beautiful music. But we're sort of obsessed with these tiny little things to find them and fix them. It's a part of our pleasure that we get out of being on this side.
Let me ask you a quick philosophical question. If what you're discovering is all the records in our collection are probably manufactured incorrectly, and everything we're doing is incorrectly, does it matter that we go through all this work to set up our cartridges, knowing that it's 5 years ago I was saying make the cantilever parallel to the hash mark, so you have no zenith error. But now we find out you have lots of zenith error.
Now that is a great question. Okay, so on the cutting side, the degree to which the engineers can err in either direction for any one of those four angles is equally likely clockwise versus counterclockwise. So if you were to tabulate, let's say across 1,000 cuts, the error of the four angles that they have to pay attention to, you would see a beautiful distribution curve, right? With the bulk of all of the cuts right in the center, right? So there's a probabilistic reason and a mechanism here for why we should say there's slop at the time of cut. Fine. But if we at Playback aim for the mean, we stand in the best statistical position to gain the most out of all records, full stop. All right, so we can't control that. We can control what we do on our side. I'm working to help develop some tools to help on the cutting side to improve their accuracy, right? Because I know that they don't have a lot of the tools, or some of the tools are very coarse. But one of the things that needs to change is the public's understanding about what they're doing when they make any particular change on their tone arm or their cartridge needs to change. Like I just released a video 2 days ago that we need to stop talking about when you raise and lower the arm that you're changing SRA and VTA. You are changing those things, but what you hear is dominated by other factors. We are not hearing the change and improvement in SRA VTA. That's one idea. Here's a second one.
What are we hearing?
Change. We're hearing the changes in vector forces in the arm. That's what's dominating. Those are the distortion characteristics that are thrown off when we change the height of our arm.
Which drives where I put the pivot point.
That's right.
In the
yes,
in,
and that's
in
just
the,
one vector force.
Which when you think about it, you've got so many different ways that you can do a bearing.
Yeah.
If now knowing this,
yeah,
why would I put my bearing points at that height and not just slightly below the tip point? And so, but that doesn't mean. I mean, I've seen pivot points right up here, and the vector force is pulling up,
and that has it.
You know, it still works. It still drags the thing through a groove, but from an optimal perspective. And by the way, the other night we just did this in a one full turn, an eighth of that, just from there to there, audible.
Yeah.
On a VTA adjustment.
Yeah.
So it's having an effect through.
But it's not
vector.
VTA. It's
not
vector
VTA.
forces.
But we hear it. We hear it.
But
So
we
we've
hear
been
it.
assigning
We hear
it
it.
to
I'm not
VTA.
saying don't change tone arm height. I'm saying let's isolate the variables.
Yeah.
And when you can change, and then the point about SRA and VTA, you know, and please speak up if you feel differently about this. All right, Cliff. So there's a widespread belief amongst audiophiles and audiophile press that when you hear sibilance and mistracking from your system, it's usually the cartridge to blame. The cartridge tends to get the blame, but it's almost never the cartridge's fault. It's almost always the fault of the tone arm being out of control with its horizontal torque forces or static friction. And it's the damper inside of the cartridge that's squealing for mercy, because it's subjected to a 6-to-1 lever arm in there, by the way. And the damper is just not able to do its job because it's being asymmetrically compressed. But we tend to blame the damper. So and then the cartridge manufacturers, they get the complaints. Hey, your cartridge isn't tracking as well as my last one. Well, you bought a race car and you had a sedan, but that's beside the point. They're getting these complaints. So what do you do when the public, and I would do this too. What do you do when the public doesn't understand these forces and understand the problem's really the tone arm? You sound like a bit of a bad guy if you're blaming somebody else and not right. So what do they raise the cantilever angle, which is getting further and further away from how the modulation angle of the lacquer is cut. Well, this solves one problem. It decreases the likelihood of the mistracking and sibilance because it increases the downward vector forces, but you're getting further and further away from the modulation angle, and that's the VTA. And we don't know, we're not aware of what we just lost, because it's the type of error of omission, not commission, right? And if we could hear what it sounds like to change the VTA at the head shell, not at the arm height, we would have a completely different relationship with SRA and VTA. Yeah, which are two different things that respond to, one to horizontal modulation, another to vertical. Sorry, on the education.
No, I definitely agree. So I never changed my tone arm height. I put it as I think would be suitable for different records, and then it stays there. When I have to change SRA, VTA, it is in the head shell, of course, because that's the only thing that makes sense. So I totally agree on that. I've always done that, never the other stuff. And also, if it comes to, if you have to change it a lot, then you really have to move it up and down to get some effect on the cantilever. So I put in a shim or whatever I need to do in order to change these angles. That's my way of thinking as well.
And just to give you a level of the scale, the average, I've analyzed several hundred cartridges in the lab. Clients send to me. The average.
Talk about that. Talk about the results of what you discovered.
Oh, okay.
Analysis.
So people send their cartridges to me for analysis in the laboratory. I analyze it for the 4 angles. zenith, error, SRA, VTA, and azimuth adjustment. And then, of course, I check out crosstalk in both phase and decibels. And so I tabulate every cartridge that comes through. I got a database now of how the industry is doing. The average VTA error. Now, ideally, we would all be at 18 degrees, but 15 to 20 is great. Okay. The average VTA is at 27 degrees, and that's dynamically measured, means under vertical, under the stylus drag, a moving record. That's 7 degrees away from the maximum acceptable and 9 degrees away from totally optimal, right?
How much of that is accidental and how much of it is done purposely?
Well, part of it is done because of this ignorance in the industry that we're not getting our tone arms horizontal torque forces under control. This is why the Wally skater is my favorite tool.
Yeah,
it's my favorite tool.
That's anti-skating.
Well, people say, well, it's just for anti-skating.
No,
it's to measure horizontal forces and static friction, right? And it's amazing when you get that under control. I mean, some people's arms are already good, but it's shocking the degree to which people say, well, I thought I had good sound before, but when you can relieve that damper,
or they say it doesn't matter. They don't believe in anti-skating.
Yeah, right.
well,
right.
That tool actually drove a change in tone arm wire.
Yeah.
So all of a sudden the wire spring forces and where you exit that wire out of a tone arm become mission critical.
Yeah.
To the point where you sometimes see rather thick tone arm wires, and the first thing you do when you take it home is you pull them out and you put the really very fine compliant and what you wrap it in, and we share that information with tone arm.
I'd like to know what wire you use.
Yeah.
Yeah, there's always a bit of spring.
So
it's
talk amongst yourselves.
Brilliant.
Talk amongst yourselves later when you want.
To your point, right? There is at least one tone arm manufacturer that says, well, my tone arm sounds worse when I apply anti-skate, to which I say, I believe you. But what was the horizontal torque force on the arm before you applied it?
Yeah.
Because if it was already headed to it was already 10% of your VTF headed to the outdoor, and then you added more force, no wonder it sounds worse. Measure what you've got. So you know your starting point. This is Wally saying basics.
This is the domain then of the turntable whisperer, that a customer, look, people who are getting into the hobby, right? We had a gentleman here yesterday. He's just getting into the hobby. He's loving buying vinyl. It's opened up a whole new world for him, and the collectability and all that stuff's happening. So for him to be thrown in that deep end, right, it's scary. So we need a, you know, if Michael's here, Michael Trey, there he is. Michael's a bona fide turntable whisperer, all right?
Indeed.
He helps the people implement. He does all that stuff for us. So it's actually leading to growth in the industry. We're in Australia. We've got I'll mention it. Hey, Chris Camilleri. New into the industry, he's gone down the rabbit hole, he's learnt how to do it. I now relax because Chris can go and help a customer out. So we went through the dark ages, I feel, which was everybody leaving, and a lot of the retailers lost that expertise and everything, but it's coming back. Young people are getting involved. They're starting to get obsessed about these things. It takes a certain personality type, but they are helping the clients make it easy. So if you're scared, if any of this stuff we're talking about is scaring you, relax. Find your turntable whisperer. They'll take care of it. They'll make this easy. Because I figured we might be frightening, like, hell, and we'll go to streaming.
And that's one of, when I do my seminars, that's one of my concerns. And inevitably somebody in the audience will say, I'm so overwhelmed, I'll just go to digital. And I say, wait, remember something. We've loved it as much as we have, being as out of control as we are. All right? This is our starting point. We already love it. The point is, there's more to get from the groove. And when you experience it, you'll never want to lose it.
One comment of what you're saying both is that one of our quests here should also be education.
Yes.
We need to
It has to
educate
be.
end
It has to
users,
be.
retailers, and everybody about how to get the best possible
Yeah.
sound. And it can go for the really high-end stuff, which we're basically talking about now. But it also goes for more basic stuff. People get scared away.
Yeah.
What is this? What do I do? We need to teach them how to deal with this, and then they get confident, and then we are rolling. So that's extremely important that
Yeah,
we
I
think
agree.
about that.
Yeah, and I realize there's some risk in scaring people away with all of the detail and the
But when
minutiae.
people come to me and say, I've got my thing set up and it doesn't sound right to me, what's wrong? And some people bring their turntables up to me and I go look at it and I see what's wrong and then I fix it and then they go, now it sounds. And one guy said to me, my wife and I sit there and we listen to records all day and night now, but we couldn't do it before. It was something was wrong. But we don't know what it was. We couldn't hear it.
Yeah.
Now we hear what's right.
When I get people calling me, say, hey, can you come to me to fix my turntable? I try to resist going to them. I warn them, first I charge a lot of money to come to you. Have you looked at my videos? Because I'd rather teach you how to fish. And that's why, when you get my tools 7 days a week, you can access me. I'll walk you through it,
Yes,
right?
right.
And I feel that it is very important. People do need this help. And once I have the initial conversation, once they watch the videos, and then maybe there's a couple emails, maybe there's a phone conversation, they get it. And then it's done. They can teach other people. And that's how it's working.
That's great. How many people are saying to themselves, I'm just going to get a CD player? I forget all this.
Yeah.
So what do we see in 5 years? What do you think you're going to find in 5 years, like in what you're doing?
Well, one of those things you touched upon, this poor little suspension, the damper that is really having a hard job. This is where we are doing a lot of work right now and have been done the last few years, and we will continue that work. It's a very crucial part. A little bit, like I said before, dumb housing, well, it's not done. Suspension, that's part of rubber. That doesn't matter. It just has to be there. Yeah, but if it's not working right, you can forget about everything else. All the parts have to work together. So from our point of view, definitely looking at the different compounds and looking at the sort of different way of suspending the cantilever is something we think could make a big difference. Basically, all cartridges are suspended, damped the same way today. Very old-fashioned. We've done that for years, but I think there is more to that. So we want to look into that as one point. Well, and also we are talking about nanometer. We need to get out of this groove.
Yeah.
So, do we have the correct stylus shape now? Could we optimize the stylus shape? What can be done? This is also something we are looking into. This. So that is.
Is there a problem in getting certain parts out of bigger industries like styluses and cantilevers are coming from only a couple of companies that really don't want to do this anymore and they're doing it just because is there a problem with that? And cutting styluses too. How many people are making those?
Yeah, micro hardness testing is unrelated to audio. They happen to use little styluses with diamond tips on it. So I think we're in a rarefied atmosphere here, right? If we can't get the diamonds from those manufacturers because they don't care anymore, then get the diamond and the cantilever, knock the diamond off the cantilever and get it glued on by someone who does care. So I see in amongst the community of rebuilders, the cartridge guys who are retipping and rebuilding, they will find a hole in that market and go, hey, I can take an old Namiki, I can knock off the diamond that was glued 15 degrees out of whack, and I can glue it on straight because I've built the tools and the jigs. Now, they'll charge for that service, but in the overall cost of a high-end cartridge, because if we're paying, say, $20,000 for at the top of the line, great sounding cartridge, and we get it and it's sent to JR and it's so out of whack, well, it's not, the manufacturer couldn't fix it to give it to us, so find someone who can, like the aftermarket hot rod guys who will take your ordinary sedan and turn it into a fire-breathing monster that can beat on Nürburgring. there's a market for that, the tuners. And so I think the passion in the industry from that sector will be okay. I'm not losing any sleep.
So you're seeing in 5 years, now you've just finished this fantastic product. Do you see in 5 years you're going to be able to do things to it to make it even better?
Well, the name of the product is GMT, Greenwich Mean Time, and it's System 1. So the system part of this description is that the whole system is made up of individual parts that is a subtractive process to create new products. So we've got a cartridge, we've got a tone arm, we've got a stage 1 preamplifier, we've got the rack, and we've got, of course, the suspension system and motor. So to create new products in the future is going to be a subtractive process rather than a create and build process.
But you don't see the top product having improvements to it too in any way?
Oh
Or you
yeah,
think
we know exactly where we're going on that already. We did a lot of work, and we've got a lot of ideas that are much more challenging to make. So we had to have a cut-off point and said, this is what we can make reliably and consistently, and we've stuck at that. But there are a lot of things that we know about which can go much further than where we are in not only the tone arm but also the motor. And long way to go.
Okay, we have only 5 minutes left, so do we have questions from the audience? Or have we covered everything and there are no questions, which is what we would hope to have achieved?
Mr. Trey.
Get the microphone.
Hi. 40 years ago, a Japanese company solved a problem that's been ignored for decades, and that's record centering. Is any manufacturer going to make a turntable that solves that problem? You're making multi-$100,000 turntables that ignore it.
Mm-hmm.
And if you look at the readout of a Fikert platter speed check, you'll see doesn't matter how little wound flutter you have, it's completely dominated by the record being a 1/4 millimeter off center.
Yeah, and that's not a problem that's just limited to pitch control. That problem extends to the ability of the damper to remain symmetrically compressed. All right, which I believe is the predominant, in my opinion, the predominant benefit of it taking the eccentricity out. But to directly answer your question, these guys would be better.
I'll talk about that because I mean it's there. It's the glaring problem. So to have an ability to move that and have it self-correct, which was beautifully done by Nakamichi in the Dragon and the T1000, and they used little hammers to tap the platter in place based on the sensor. So the very material that they're sliding around underneath the record, because you wouldn't want to tap and damage the record, created an eccentric vibrational problem in the platter. So yes, it centered the record, but it generated another issue, which we can see in the suspension system.
Yeah, it didn't sound good after.
So ultimately, sonically, it needs to be solved. Michael, totally agree. I've looked at the problem. I haven't found out a way of doing it yet, which avoids that. It needs to be self-balancing and have some adjustment for that.
I think if that's a concern for you, then I think DS Audio have got a device which can easily address
at the moment
problem.
Optically measuring it and then adjusting it by hand is like they do on the lathe.
And it works. That thing works great.
wonderfully.
It does work, yeah. So
It's just time consuming.
it's much less intrusive on the other aspects.
And
of
people
the,
say, you're going to do that for every record? Well, I clean my stylus for every record.
I don't. After
So
the first
I put
glass
that
of whiskey,
I put that device on,
stuck it
and then
play.
it's centered. And when you hear that, I mean, at the Warsaw show 2 years ago, they used that to play an Adele record, and everybody in the audience could hear the difference with an Adele record, which is not like long sustained notes, except when she was warbling, but it worked.
Yeah.
Yeah.
So there is a solution.
It's not done automatically for you. Craig's got automatic VTA now. We can sit in and adjust with our phone.
You mean automatic
So
height
vector
control.
force adjustment. Yes.
We got to change the language.
Yeah.
Right? Yeah.
And
I put that in my review. You hear a difference, but what are you hearing?
It's not VTA. It's
But you
something
do hear a
else.
difference.
Yeah.
The fact is, you can hear the difference from your listening position.
Yes, you can.
You're
It's
not
just
stood
not
next to the
VTA.
record player out of the central focus of the stereo image that you're supposed to be evaluating.
To push a button and have the arm go up is really nice when your
Oh, I
phone
agree.
rings or your wife comes down and says, "Turn that on." You can push the button. It's a nice
All
thing.
digital.
Yeah, right. Exactly.
Yeah. Yeah.
No more questions. We have 2 minutes, and we're very precise here in Munich. Anybody else have anything they want to add to this discussion?
You asked about the next 5 years.
Yes.
Of all the cartridges I analyze, 1 out of 8 do not meet manufacturer specifications. Okay? Congratulations, by the way, to Ortofon. You have like perhaps the best record in terms of that issue, right?
Okay, thank you. I'll
You guys
tell
are
you later.
keeping that controlled, which is wonderful.
You
But a
seem
lot
to have been saying there were some other issues that they don't get so well.
Oh, no. No,
To
there's
clarify
no
that.
implication there, but there's a real. I'm hoping that while I'm making friends and enemies, that some of these cartridge manufacturers are going to listen and they'll work me out of a job, and I'm all right with that, right? If they get this stuff under control, I'll have to find something else to
It's
do.
okay to make enemies. Trust me. It's okay.
Yeah. So there's hopefully we see in the industry, they start paying attention to what they get from their vendors as well as what they're doing with the final assembly.
So I want to thank everybody for participating in this panel and for all the work that you're doing to make this better, and it's gotten better. And I think for every one of us, the fact that we're here talking about vinyl, and vinyl is all over the place downstairs, and we're all playing records, is like a dream come true for most of us, for many of us, for our playback. Because if it had gone the other way, I'd find some other work. I wouldn't be doing this. So thank you all for coming, and I hope you found this useful.
Thank you, Michael.
Thank you, Michael. Great.